At the previous lesson, we had brief introduction into the course. I'll look it through class plan, and I'll explain this to the best what I could, and ask it you if look it through. If you have any questions, concern, please write it up, either through message or in class. So I'm asking in class, do you have any questions or concerns about it? Not yet? Okay. So if it comes up later, just send me a message through Slate. It will be the best way to address it. So, except outside of the class. Outside of the class, the best way outside of the class. The best way is actually in class. Unless you have kind of privacy concern, of course, this way it's message. So, class plan covered at the previous lesson. Initial software installation also covered at the previous lesson. At the previous lesson, we installed Git. We installed Android Studio. We made sure that it works. It was issue on one laptop. Somehow it probably a specific laptop issue for that student. Hopefully it is resolved. Is it resolved? Yeah, cool. So sometimes it happens, and because although everyone using similar operating systems, like either latest Windows or latest Mac, but it's still there are some hardware could be different in some very little sense. Different, it may cause something. Okay, so. I posted course resources, and I want to briefly talk about it. Because I didn't post it before, and we didn't discuss it. So course resources is PDF file that I posted, and it is what links to the most information that you could find related to the course. This is primary guideline for what I put inside. It is a course, composed course from Google. It starts from very basics. It doesn't assume knowledge of Kotlin. It doesn't assume most of the stuff. It assumes some experience in programming somewhere in some form. This is it. This course is progressing extremely slow. This is the reason why it is progressing slow. It doesn't assume much of the programming experience. So if you want to go through these slides step by step, the same lesson material will take several times longer. So this is why I cannot repeat it in class. And as a side effect, it ends very soon. Okay? It ends before this course ends. So it has less stuff in it. What does it mean? It is definitely, in the beginning, it starts developing programs, the shortest possible scenario, without paying too much attention to organizing the code. It is related to the fact that students who take this course like primary source of information, like target audience, without assuming a lot of programming experience. So they try to keep the code the shortest possible. And the shortest possible code is not the easiest to edit afterwards. So in order to add features, you will have to make it bigger, and rewrite. So the better approach is just to use reasonable code organization from very beginning or close to the beginning, and after this add features without rewriting entire piece. So this is the feature of the course, or feature of the course. In the beginning, code is not well organized, and after this, they start to add things. First, applications, they're not really applications, they're just demonstrations of layouts. So it's just static, let's display image in the middle of the page, something like that. And first application that is actually working, it is dice roller application. They have image of a dice on the screen that is replaced by pressing button into random image of a dice. So it is like a kind of rolling dice imitation. In the first lesson of the next week, we will create something together in class, right starting with that. And I will discuss layouts at that point as we create it. So this is my approach, just skip programs, just show layout itself. We will do it in class while we create it. I will pre-create it at home to make sure that it turns out well, so I will have code in front of me and kind of walk through it together by typing and explain as it goes. Another course, this one, it really assumes a lot of previous Android knowledge, but not GUI knowledge, because there are two kinds of GUIs. In Android, older and newer one, it assumes lots of experience with older one, but very little with new one. So this, or no, with new one. It is not suitable for this course, but in the beginning, but maybe later it is. Jetpack Compo, this one, sorry, this one. I was talking about for developers, Android developers. This is a course that I mentioned. It is not linked to the front page or anywhere in obvious place to on the developerandroid.com, but it is still there, developerandroid.com. This course is seriously defective. It is missing pieces that are necessary to understand it. And this is probably why it's not at obvious place. But it is only a reasonable explanation that exists how to link Firebase Cloud and Android. Unfortunately, this information is not immediately obvious anywhere, and this is only resource, unfortunately. That has a reasonable explanation, but unfortunately, it is missing a lot in order to be consistent. Since you are taking this in class with me, and I will try to use some of it, I will provide missing pieces, hopefully, and it will be easier to follow. And again, this is linked. It was used to be linked to the front page, but now it's not. And the reason is probably just it has issues. Teach Android teach Android development. This course is used for slides that you saw in the beginning, and I will use slides for classes and classes and objects today from it. When it goes into GUI development, it is old GUI. And don't go there at this moment. Later, if you need to edit older code for small changes, you probably need to learn it. But don't go there now, because it is a totally different approach, and it will just add extra confusion. Newer GUI, it's called Compose. Is designed in such a way that you can put older GUI inside of new and new inside of old. You can have pages entirely in new and pages entirely as old. So it is made compatible on purpose, so already existing applications can be ported step by step, and new features will be added new way by keeping older stuff if necessary. Developing applications such way takes far more effort and time than doing this from scratch new way. This is why it's not taken in the class. In the course that mentioned first, there are two labs that show how to insert older GUI into new one and newer into old one. You're welcome to go through, but in the beginning, it doesn't make any sense. It's closer to end. Okay? There are two labs like with step-by-step instructions. They will not make sense right now. It's closer to end. So this is about courses coming from Google. References on developerandroid.com website that I already mentioned. Besides it, there is a specific website for the language of Kotlin. This website contains simple tutorials, simple introductions. It is not just reference. It's a good idea to browse. There is also a website, developers.google.com. It is not Android specific, but Android is somewhat mentioned there because it's developers of Google. But it is, and it has links back to developerandroid.com. There are two video tutorials, quite good one, about Kotlin, just Kotlin. Second, it is quite advanced, but not useless in this course. It goes into depth, but probably not immediately. Later you can look at. And if you feel confused with Kotlin, or you want to do it step by step, like with video tutorial, consider going through that. It is very good. and it goes far deeper than I do. Okay, both together goes far deeper in code to Kotlin than I do in the course. So they have quite reasonable date. I believe it's kind of perhaps there is a newer version, but it is linked to the same place. So we can just click on it and see what is updated on. No, it is still updated. I released it. Not Kotlin did change, but not drastically since that time. So it is still current. Android itself is changing a lot, but Kotlin as a language is changing slower than Android. These two, there is also very extremely long tutorial, 25 hours, specifically for Android, this one. And unfortunately, it is using older version of Compose. It's not older GUI, which is object-oriented. It's still Compose, but it is older version of Compose. Unless last time I checked it, unless the teacher redid it, which is unlikely because it's too much. He is doing this absolutely at slow pace. I assume that he was either paid by hour of the video. How longer video more pay? I don't know. It is extremely slow, everything. Code will not work if you download it and run. You will have to edit it before it runs, because if you want to copy paste. There is issue that comes with this course and these old textbooks, all of them, actually. Material design interface to Compose was changed a lot between Material Design 2 and Material Design 3. And unfortunately, code is not copy-pastable between Material Design 2 and Material Design 3. A lot of it is copy-pastable, but you have to edit some things in order to make it work, because it just says such function doesn't exist. You have to replace those functions with different APIs in order to make it work. It applies to all these textbooks listed there. They are not useless to look through in terms of understanding theory, but in terms of copy-pasting, it doesn't always work, because it is using Material Design 2 API, which is not always copy-pastable into Material Design 3. When you create project from scratch, by default, it comes with Material Design 3. Technically, it is possible to replace libraries in the project, but why would you invest time in learning all the stuff? So this is about books and about that tutorial. There are YouTube channels that are useful to look, but they're not like step-by-step tutorials. It's just for extra information about what is going on, essentially. These blogs just on specific topics of Android development. They are not like from everything from scratch. And this one, this blog, it is the basis of that course that, what I mentioned, where they removed the link. So essentially, this blog is theoretical content for that course, which is not linked to front page anymore, but it exists. Okay? And actually, that course was providing information by linking to this blog. She provided two versions of the code. First version of the code for it was used 1 year ago when I taught this. Code wasn't great. It has lots of issues. I had to fix some of it and made it better. It was first iteration, so I understand why. And she completely rewrote it. And it is a lot better, but she rewrote this in winter and beginning of spring. So now we have better code. I used this code in video introduction to Firebase in the summer. And we will use some version of it, newer one. Unfortunately, when we look through the code here and screen captures, it is older. It is the first version of the code, not second. She didn't update it, but theory is still all right. Pictures are kind of not matching. Code, what she pasted on the page, also not exact match. But theoretical discussions is perfectly all right. So this is very good for theoretical discussions of basic concepts, what she's using to write this code. So this is a brief introduction to resources. There is one textbook that is publication date September this year. I look at the book because previous pre-release version is available online. There is 2 websites that covers it. One website has chapter 1, chapter 3, and chapter 9. So it's not really a way to go through. Another website that has pre-release version of this seems to have most of the chapters, not all, but formatting is so awful that it's unreadable. So text on top of the text, on top of the images. So currently, it's not really a way to go. It is newer version of older textbook. Older textbook was done for previous GUI, which is completely different, object-oriented. And it seems like the authors rewrote the book using Compose. And previous version of this book was the last book covering older GUI. No more. Okay, so older GUI is on the way out. So this was a brief review of sources available. And some things can probably exist, but I'm not aware of it. I'm trying to stay current by looking up, but I'm not aware of this. I'm not hiding any secret information. It's just I don't know about it. About course resources, about exercise 1. I already mentioned in the beginning of today's lesson that it's a good idea to try to do exercises as best as you could in order to develop your practical skills. This is the only way how you can do it. Another thing that I encourage is just to try to do some practicing on your own. Pick something which is interesting to you and try to create an app. Or try to, in the beginning of the course, try to make it use command line interface or business logic Kotlin classes. You don't have to stick to this exercise if you imagine something about the same complexity, just go for your own version, as long as you're doing practicing. So what is it about? Today we will discuss business logic of an app that is designed to quiz, make some kind of, not quiz, but training of math, like 2 + 2, whatever. What is your answer? It is generating random problems, and it has options to grade this, but it doesn't have a front end in terms of user interface. It has business logic for creating problems and problem classes and so on, but it doesn't have actual interaction part with user. We will discuss those classes. Hopefully, it will be straightforward how they work today. I'm asking you to write front end for it as command line, like console application for it. Definitely, it has several problems. Probably you will store it in list, so you will have a loop to go through this list. You will need to have an if to check if answer is right. So, and display stuff on the screen. You need to update some counter variables, like how many problems are right, how many right answers, how many wrong. If you implement the feature, like try again, you will have another loop inside till answer is right, or if it is fixed number of attempts with loop and a break inside, like when answer is right, you break out of it, and counter for number of attempts. So it is not immediately straightforward, but it shouldn't be challenging. So consider doing it. Either from scratch or starting from the code the way I explain it in class. I will explain it in class. I would prefer if you go starting with the code, explain it in class, because you reuse classes existing, you will go through and learn from it. If you want to start from the scratch, it's better than doing nothing, for sure. Okay? So this is my recommendation for probably tomorrow or tonight, practice with it. Today, at the previous lesson, we had a brief introduction to Kotlin, and what we absolutely didn't cover is classes and objects. And today we will discuss it and do it in practical sense by creating classes and objects. And after this, I posted 2 examples with more advanced implementation of classes and using objects. One, it is dice cube example, and also they do have testing cases. Today we will learn how to generate automatic tests for a class. Automatic testing for these classes are generated exactly the same way. So there is no extra theory in it. And it does have more code in it. Just we'll briefly go through. You later look through probably deeper into that and hopefully learn a little more from it. These two versions of the code have branch that is only text-based. Dice cube doesn't have GUI branch, and that branch will be created in class together. So it has only business logic part in it. This program has default branch with only business logic, and it has a GUI branch. So if we switch branch, today we will learn how to clone project and switch branches, you will have an entire app in it. And it's also kind of demo of how a small application will look like. It is still a small application. It has only 1 page, but it does have fancy things in it. It will be explained in week 3. And your assignment will be also posted on week 3, due on week 4. Today we will run it, so you will see what it is. Your assignment will be also 1 page with some interaction with the user. It will be guess a number. Okay? With some clues, interaction with the user. Okay, guess number between 1 and 10. For example, user enters 6. It says, no, the answer is larger. So it's a loop in it. And user enters 7 and says, no, answer is larger. User enters some, I don't know, 9. It says, no, the answer is smaller. So 8, yeah, you're right, congratulations. This kind of app. Okay, it looks like it's absolutely elementary, but GUI is not. And the primary goal is to create a GUI. GUI is using approaches that you are not necessarily familiar with. This is why it is still challenging, okay? It's not hard to do it in command line, absolutely not hard, but it is, GUI is challenging, okay? And it is somewhat similar to that, but this is more complicated because it has a fancier business logic, because it needs to create problems, go through that, and grade problems. It's not just guessing 1 number, okay? So this is where we are. Previous lesson was recorded entirely. There are two files, before break and after break. As I noted, the file, it's a link to YouTube. So let's dive in into this second lesson of the course. And Kotlin basics covered. In Kotlin functions, I didn't cover, in the slides, I didn't cover processing lists with filters, because it will come up later in the course, so I'm postponing it. We will use it really, really a lot, but not right now. Let's talk about classes. These slides already mentioned where they come from. They're coming from. It is the course that contains Kotlin and older GUI, and this is last useful set of slides from it. It doesn't cover all theory from the today. It is just introduction to what we're going to do. We will learn more about classes and objects today. So classes. Idea of classes in Kotlin is extremely similar to idea of classes in other languages. A class is a description of objects to be created later in the program. It is like a blueprint of creating something. It is description, but not actual objects. What is a class? It's a brief reminder. It is description to create an object, and this description describes data associated with the class and functionalities, right? Or that functionality is called methods. And in Kotlin, it's just functions defined inside of the class. There are two kinds of functions and data defined in the class. Data associated with specific object, and this is called instance data. It's not associated with class itself. Data associated with class itself is stored in companion object. And companion object is shared through all members, through all objects created from the class. In other languages, companion data and companion functions are called static data and static functions. So you're familiar with keyword static from such languages as C#. Static data means this data will be shared between all members created from the class. It is implemented differently in Kotlin from Java and C#. They use companion object, which behaves the same. It is companion object inside of regular object that will be shared between all instances of it. You can access companion data and companion function without actually creating an object, because this way you refer to the name of the class, not to the name of the variable. So this is brief differences between C# and Kotlin. Also in Kotlin, all instance functions, not those that belongs to companion object, instance functions are virtual, and it is the reason why we don't have virtual keyword, because all instance functions are virtual. There is also differences in inheritance. By default, in Kotlin, you cannot inherit from the class unless this class is declared open. Okay? In other languages, you can make the class final. For example, in Java, it means inheritance from this class is not allowed. In Kotlin, inheritance from the class is not allowed by default. You need to declare this open, or class has to be abstract. Abstract class, it means it is designed as parent class for something else. It is designed for inheritance. This is why open keyword is not explicit, because abstract means it's meant to be inherited from. There are also interfaces. Interfaces in Kotlin, idea of interfaces in Kotlin is extremely similar to idea of interfaces in C#. In inheritance, you can inherit from any number of interfaces and only one class, just like in C#. So this is brief comparison with C# classes and Kotlin. I will also use column in the inheritance like in C#. So what we define here in class, they are instance variables, but technically it's not variable. It's a property. So what you will see here, like color, it is not just value. It is value with setter and getter. With set method and get method. Set get method and get method, they assume it and they're under the hood. So this, and when you assign to it, it's public by default. When you assign it to it, it is calling set method under the hood. It is done to stay compatible with Java. In Java, you can have public and assigned like that, but best practice in Java is to have a value and set and get. In this case, it's value with set and get implied. Okay? You can override set and get yourself, and we will see how to do it. It makes sense to override set if you want to enforce some rules on the value. For example, you have age, and you want to enforce rule, it shouldn't be below 0. Okay? In this case, you override setter, and you throw exception in this setter for the property when user tries to assign negative number to age. So they are properties, value with setter and getters. If you don't specify them explicitly, they will be under the hood by the system, implemented by the system. And this is member function, or another word for this, it's a method that has access to those properties. By default, all functions and all properties are public in Kotlin, unlike some other languages. They're public. There are also private and protected. Meaning of private and protected is the same as in C#. If it is private, you can access only within this, by the functions of this class. Right? If it is public, anybody else, anything else can access it. If it is protected, only classes that inherit it from given class can access it. So meaning of it, it is exact match to C#. In C# you can have functions that are not virtual. In Kotlin, all functions defined in the class are virtual. There's no way to make it not virtual. Okay. When you declare values, you can assign initialization similar to other languages. And this code, what you have, will be treated as part of the default constructor. So default constructor, unless it takes parameters, it's not explicit. It is just assigned here. If you need to pass parameters to default constructor, you pass it right here. You open parentheses next to name of the class, which is totally different from C#. In C#, when you declare a constructor, you just do the name of it and parentheses after it, right? But in Kotlin, you do parentheses here. You can put empty, but empty parentheses can be omitted. But in class declaration, if you put parentheses here and parameter, it would be value for kind of default. Constructor default defined in this way. And if you want additional constructors, you can define them using keyword constructor. You don't repeat name of the class, you just use keyword constructor. So grammar is different from C# in this sense. As you see, semicolon in the end of the line is optional, and if you put them, a compiler, Android Studio will annoy you to remove it. It will say, you don't need it, okay? But you can put it, it will compile, but you'll get warning. So these are parameters of the constructor after the class. Okay. If you do not put keyword val in front of it, next to the parameter, it is just a value passed to constructor. If you put val or var in front of it, it means create property and pass this value to it. So it's a shortcut to pass value and create property. Okay, this is for var and val. So this is what it means. This is just value passed to the constructor, so you cannot use .x after that. If you use val, you can use .y, because val means create property for it. And as you see, curly braces are omitted because this class doesn't have anything inside. Okay. In this case, you can omit curly braces in class declaration if it doesn't have anything in it. You can use the default parameters. Okay. So this is to the constructor. And this is how you call it. Sorry, you can use default parameters. This is default parameter. And you use name of the parameters when you call it. If you don't provide parameters, it will use default. The same as the functions, for functions. So technically, what you have here right? And it is this. But you don't repeat word constructor if you have only one this way. If you need additional one, you just repeat constructor, constructor. But those constructors must call default one, this one. It is a strict requirement. You can have only one constructor which on its own, other should call it, or should call another constructor calling it. Okay. If you need to execute some code inside of the constructor, not to just declare variables, we use init block. It is for extra code to be executed outside of assignment. You can assign by calling function. It's also code. But if you need to create some kind of loop, you need to use init. You cannot really assign loop to variable. Right? So this is for code, which is not just simple call and assignment to a variable. Okay, multiple init blocks are allowed. Okay. I call default constructor. Technically, its proper name. It's primary constructor. So default, it's primary. Default, it is without parameters. But primary can have parameters. So in this case, this code will print stuff. All right. In order to, when we call constructor in Kotlin, we do not use keyword new, which is drastic difference from C#. So there is no new keyword in Kotlin at all. It doesn't exist. Secondary constructors, it means any other constructor besides primary, must call primary constructor. Okay. It is called from the declaration line by using column. I believe, am I right? Yeah, you see? So this is primary constructor. This is secondary constructor calling this. This is also secondary constructor calling this. You can also define secondary constructor calling this part. So they kind of chain it. Calling this, and this is calling primary. It's also allowed. And init block will be executed for primary. This is why it will be executed for secondary, because secondary is calling primary. Okay. In order to access properties, we use dot notation like any other language. So this is using dot. And in order to assign, just use. This is assuming primary and var. You cannot assign to val outside of it, because val is initialized inside of the constructor, and it's fixed. We learned about val and var. Val can be assigned only once. Var can be reassigned. And this is how to override set and get for property. By default, set and get is assumed under the hood. But if you need to change it, you can override it. Sometimes it is useful to create a property which is calculating value. For example, you have a rectangle, and you have width and height, and you have property area. And it will calculate it on the fly from width and height. In this case, you define it as val and get. And after this, if you refer to rectangle dot area, it will call getter, and getter will calculate it. It's also used for manipulation. Okay, and getter can do other things, for example, print stuff. And in this case, it is calculating string like a name. This is what I mentioned, from first name and last name, using template. Right? So full name is join it first name and last name as a string. So this is calculated value. So calculated is defined with val and using customized get. And this is a customized set. you assign value, it will split on space, and it will assign first name and last name. And it will also store the value as am I right? Yes, and it will also store the value for full name. This is how to refer to the value inside of setter. Okay. If you use person full name, it will call getter by default. This is why you cannot use that variable here. So if you write full name here, it will call getter right here. It will not, sorry, not getter. If you assign to it, it will call setter. If you mention somewhere to retrieve value, it will call getter. This is the reason why you cannot use here, because you will get infinite loop. If you write full name right here, it will call setter in infinite loop. Because you assign to it and it will call function itself. This is the reason why we have to use field, not this one. Because assigning to the value is calling setter. Inside of the setter, it will create infinite loop. Okay? We will use it today. Customize the setter. Function classes use fun keyword for inheritance. Inheritance in Kotlin you can have only one parent class, but as many interfaces as you like. Interfaces can have properties in Kotlin. Why? Because properties of interface is just get and set functions under the hood. They do not carry value. So this is why we can have properties in interface. Properties in interface, I assume just set and get. Both are virtual, so they overwritten in child classes. Not just child classes. Classes implementing the interface. So we have, for example, interfaces. What is interface? It is expectations, right? If expectations for something else. For example, you have an interface person with first name, last name. You cannot create objects from it directly, but it is expectation for something else that has first name and last name. In interface first name, last name, they just setter and getter under the hood as virtual functions. And so this is why you can have them. They do not carry any data inside of interface. Data will be inside of classes implemented and overriding under the hood setters and getters. Okay. So for example, interface shape has a function compute area, and you have a circle implementing this interface with the inheritance from interface the same as in C#, it is column. Okay. And when you implement function of interface, we use override. The same as when we override function from a class or abstract class. Okay. Extending classes, it is by inheriting. By default, you cannot inherit from the class unless it is declared either abstract or open. There is also a type of classes, call it sealed. Sealed classes. You can inherit from sealed classes only inside of the class itself. You create class inside of the class, or another class in the same file. This is called sealed. Interfaces can be also sealed if you implement interface inside of the class. If you declare class implementing interface right inside of curly braces of interface or inside of the same file. So this is the meaning of sealed classes and interfaces. If you say sealed abstract, a compiler will warn you that in this case, In this case, abstract is not necessary. It will work fine if you omit this word, but you can keep it. Okay, declare class, this is inheritance from it. When you declare class that is inheriting from class, you need to call constructor of it. If you inherit from interface, you don't call constructor. Even if you inherit from abstract class, you can call you need to put parentheses like calling constructor of abstract class. This is a difference from calling constructor in a code of abstract class. You cannot call constructor of an abstract class in a code, but you need to call it when you inherit from it. When you overwriting, you use it with keyword override. If you want to make some function not overridable, you declare it with keyword, extra keyword final. So this will not be overridable in child classes. Abstract, it is class with partial functionality, and it is designed to be inherited from. And it is assumed open, because there's no other way to use it. So abstract class food has two abstract properties. In interface, they are abstract by default. We don't write abstract in the interface. So two abstract properties. And it means there are only setters and getters here. There is no value if it is property is abstract. And this function is implemented. You can have function which is abstract, means no implementation. It will just end with right here. Abstract function consume. Okay, and pizza is inheriting from it, calling constructor of abstract class. This is what I mentioned. It has to be parentheses. And it is declaring properties that override, and these properties will store data. And this is how to use it. You call constructor of pizza class and call consume. Implement it in parent class. Okay. When to use each, it's not always immediately obvious. When to use each, sometimes you have to experiment with it. Extension functions. Extension functions are functions defined outside of the class that behaves like they belong declared inside. So it is a useful feature to add functionality to existing classes. For example, you have a class from a library, you cannot really edit the code, but you can create extension functions that behaves like they belong to the class. Extension functions can access only public stuff from the class. It cannot access private. And I don't think it can access protected, but I'm not sure. Check it if you care. Okay. Extension functions can be added even to such things like as int. We know that int behaves like a class, but under the hood it's just a number. Compiler makes it look like it is class. So you can add extension functions even to that. For example, you can do int.asOdd and implementation of it, like returning calculation Boolean expression is odd or not, and call it on 3 and it will work. Special classes. Data class is super useful. We will use it a lot, including today. A data class is primarily designed to carry data, but it has limitations. You cannot inherit from data class. This is a restriction. And it comes with additional features, extremely useful. For example, toString, not extremely useful, but toString. It means you can print it nice way. But in my opinion, the best property of data classes is copy function. In Android, we have to copy a lot for data consistency because we use, say, immutable objects. So in order to change data inside of immutable object, you need to create new one. And copy function in this case is super useful. With copy function, you write only things that you want to change, and the rest is copied by default. There is also hash function implemented in it, and toString and more equals functions implemented in it, where that compares values. Data classes are extremely compact. If you don't need to add extra functionality, you just declare it by without curly braces, and it will create these values inside. With additional features like a hash function, then what else I mentioned? ToString function and copy function, and perhaps more. Okay. Pair and triple less useful classes. It is just to store 3 things together and 2 things together, just random stuff. To access it, you can use first, dot, second, and third. They are less useful if use it only when you as a shortcut without declaring extra things. Otherwise, consider declaring own class, which has more meaning in it than just pair or 3. Pairs can be created by using to, and when you use to, it is dot is optional. Pairs are used typically as inputs of some functions. For example, creating maps. Maps, it's key value pairs. So you provide pairs using to this function. So this is probably the most useful part of how to use pairs. So map, it is key value pairs. So you create pairs, provided this parameter to create map of. Enum class will be used today. It's also super useful to create readable code. It is not just set of integers. You can do other things in it. It's more interesting. By default, it will be 0, 1, 2, blah, blah, blah. Under the hood, when you print it, it will be just name of the variable, which is also convenient to see what is going on if you print stuff. To refer to this, you use name of the enum and dot and this piece. It can be more complicated. Instead of just numbers, you can create objects for it and put it inside. And you can create even methods there. What is object? Object, it is similar to the class, but it's already object. It is used in the cases when you need only one, like object calculator. And you refer to this by the name of the object. So calculator dot and what you dot add. Also useful manipulation. Companion objects, it's a companion objects declared inside of the classes. This object will be shared between all instances of the class, and you don't need to create instance in order to refer to companion object. We use name of the class to refer to it. For example, if this is inside of companion object, you can use class name .z. Okay. This class has companion object storing gravity. It is constant, right? 9.8. And this value will be shared between all objects created from this class. And you can refer to this by name of the class and name of the companion object. But this is optional. If you do not declare it here, it will be just .gravity. So this part is optional. It is declared here in case you want more than one with different names. Organizing your code, it's a really large topic, right? You have software design course, software engineering course. The best principle to use it is separation of concerns. Don't forget about it. If you have different purpose, use different things for it. Okay? Essentially. Packages. Packages are used to separate concerns and to also to avoid naming conflicts. So it's like namespaces in C#. Okay. We can have package inside of package, similar to namespace inside of namespace. In Java, we had limitation that a package structure must match structure of folders of the code. In Kotlin, there is no such enforcement. In summary, so that was brief introduction. Perhaps we need to have a short break, right? So let's have a short break now. 1 second. We started at 8. No, yeah, it's time to do short break, right? So let's have a short break, like 15 or 20 minutes. What do you want? 15 or 20? Does it matter? If it doesn't matter, 15. Okay. So 15 minutes starting now.